So partial differential equation, multiple choice questions. First one, the complete integral of p equals q is. This question under the category f of pq equals 0. This is type 1. For type 1, p equals q. So let z equals, the procedure for solving type 1 equation is that z equals ax plus by plus c be the solution to one. So differentiate 2 with respect to x. Dou az by dou x equals a, that is p equals a. Similarly, when you differentiate with respect to y, 2 equals b. Substitute your p and q in 1. Now your 1 becomes a equals b. So substitute a equals b in 2. 2 is z equals ax plus b. In place of b also you can substitute a plus c. So ax plus ay plus c can be considered as some b, other constant. So z equals x plus y, a is common, plus b or c. But in this objective type questions, the option is a, x plus y plus b. B and c are mere constant only. So 2 is the solution for this expression. Next one. Next question. Complete integral of q equals question number 2. Q equals 2py. So this is pqy, 4-letter word, that is type here x is missing, but this is under the category of pqxy type 4. So for type 4, just combine q and y term on one side, remaining terms on other side. So q divided by y equals 2 times of p, which can be equated to the constant either k or a. So here they are using the constants a, so that's why I am taking a. So compare q by y equals a, 2p by 2p equals a. Q equals ya and 2p equals a. For type 4, the solution is dz equals integral p dx plus integral q dy. So z equals integral, the value of p is a by 2. So from this I can extract the value of p as a by 2. A by 2 dx plus q value is y into a. Now integrating this expression, z equals a by 2 is constant x plus y integration is y square by 2 plus y square by 2 into a and integrating constant is b. Now z equals 2 is LCM here, ax plus y square a plus 2b. Ax plus y square a plus 2b. So this entire term is considered as a single constant. So we have to give the generalized form. So ax plus a y square plus b. So this is our answer. Next one. Next one. Question number 3. The complete integral of p. The complete integral of pq equals 1. pq equals 1. Again this is type 1. For type 1, z equals ax plus by plus c be the solution. So when you differentiate z with respect to x, which will be p. P equals A and Q is equal to B. Now substitute our P and Q value in PQ is equal to 1. So AB is equal to 1. Either you can take A is equal to 1 by B, or you can consider B is equal to 1 divided by A. So Z equals, here in our solution they are using the only letters A and C. So AX plus B value is 1 by AY plus C. So AX, question number 3, AX plus AY, when I consider A as LCM, A square X plus Y plus AC. So AZ equals A square X plus Y plus AC. So first one is our answer. Now question number 4, PQ equals X. PQ equals X. This is type 4. So if you heard about P, Q, X, Y, these 4 variables are in your question. So which will be considered as, this is type 4. For type 4, what shall we do now? Separate your P and X term on one side, Q and Y term on another side. Right. Yeah. Now PQ equals X. This is question number 4. PQ equals X. P Q equals X by P and equate finally to the constant. So now Q equals A, X by P equals A. Q equals A, X by P equals A. X equals, and P value is X divided by A equals P value. Our solution is dz equals P dx plus Q dy. So integral dz is Z. P value is A. P value is X by A. X by A dx plus Q value is A dy. Now Z equals 1 by A x square by 2 plus AY plus some constant. Either you can add B or C. So here they are adding the constant as C. So first we will simplify this expression by taking x square by 2A, AY plus B. So here the first option is C. So instead of B we can use C, that is mere constant. So first one is our answer. Next one, the partial differential equation formed by eliminating arbitrary constant. In this question we have to eliminate the arbitrary constant A and B. Okay. Now we will move to question number 5. Question number 5. The partial differential equation formed by eliminating constant x plus a, y plus b. Just we have to eliminate the constant a and b. Now differentiate with respect to, this is 1, differentiate with respect to x. Dou z by dou x equals, x is 1 and y plus b. Y plus b is a coefficient. So p value is y plus b. Similarly, when you differentiate with respect to y, x plus a is coefficient, y is 1. That is q value is x plus a. Now substitute your p and q value in our given equation. X plus a value is q, y plus b value is p. So z equals pq. Z equals pq. This is our answer. Next one, question number 6. Question number 6. The partial differential equation formed by eliminating arbitrary constant. Again we have to eliminate the arbitrary constant in question number 6. Ax plus by plus ab. So simply just differentiate with respect to x. Dou z by dou x. A. That is p equals a. Dou z by dou b. Dou z by dou y. When you differentiate with respect to y, x and other terms are constant. So when you differentiate with respect to y, y is 1b. That is q is equal to b. Now substitute your A and B value in the given equation. Z equals A value is P. Px plus Qy plus Pq. So this is Clairaut's form. So this is our answer in question number 6. Next question number 7. The differential partial differential equation formed by eliminating arbitrary function. Question number 7. Z equals f of x square plus y square. We have to eliminate the arbitrary function f. Dou z by dou x. So first give the differentiation for the function f. F differentiation is f dash. F dash of x square plus y square, and then differentiate x square plus y square. Since we are differentiating with respect to x, x square differentiation is 2x, y square is 0, constant. Hence p value is f dash of x square plus y square 2 times of x. Similarly q, when you differentiate with z with respect to y, which will become dou z by dou y. Dou z by dou y is q. F differentiation is f dash of x square plus y square, and now we are differentiating with respect to y. When you are differentiating with respect to y, x square is constant, y square is 2y. Now we have to eliminate the term f dash term or f term. So here we have to eliminate f dash term. So if you consider this is 1 and this one is 2, so how can we eliminate f dash? 1 divided by just dividing 1 by 2. So in the left hand side p by q, in the left hand side p by q, right hand side f dash get cancelled, 2 get cancelled, x divided by y. By doing cross multiplication, py equals qx, py equals qx. So third one is our answer. Option 3 is answer. The next question. The general integral of z equals, question number 8. The general integral of z equals xp plus yq. So which method we have to use for solving this PDE? So we have classified the first order partial differential equation as per the arrangement of x, p, y, q and z. If z equals px plus, so in only 2 types contains all the 5 letters x, p, y, z, q. So if z equals px plus qy plus some function of p comma q, which is under the category types 2. This is Clairaut's form. But here in the one term contains small p term, the coefficient of which may be linear or non-linear. So the coefficient of small p is considered as capital P, and this coefficient of small q is considered as capital Q, and the rest of the terms are considered as R. So this is Lagrange's method. So we are going to solve this problem in Lagrange's method. Okay. Lagrange's method. Capital P is coefficient of small p. Here coefficient of small p is x. Capital Q is coefficient of small q. Small q coefficient is y. And the term which is independent from p and q is considered as R. R is z here. So first we have to write subsidiary equations. Subsidiary equation. The subsidiary equations are dx by capital P, dy by q and dz by r. Now substitute all the values here. Dx by p, dy by q, that is pi, dz by r. R is z here. So now we can equate 1 and 2, 2 and 3 or 1 and 3. But we have to use variable separable method. That is, combine the term x along with the dx, remaining term that is y along with the dy, z should be combined with dz. Now I am going to take here already dx term contains x term only, dy term contains y term only, dz term contains z term only. So I am going to compare 1 and 2, after that 2 and 3. So case 1, dx by x equals dy by y. Just integrating on both sides. Dx by x, dy by y. dx by x is nothing but log x. Integration of dy by dy is log y. Since these two terms contains logarithmic term, I am adding the term constant as log c. Now, log x minus log y equals log c, and log x minus log y, log x log, which is of the form log m minus log n, which can be written as log x divided by y equals log c. So log and log get cancel, x by y equals c, and finally x by y is equal to some constant u, in final constant u, x by y is equal to u. Similarly, if you equate y and z, we will be getting, if you equate dy by y equals dz by z, we will be getting y by z is equal to some v. But the solution for Lagrange's method is phi of u comma v equals 0. Phi of u value is x by y, v value is y divided by z equals 0. So x by y, y by z. Option 1 is correct. Next question, question number 9. PQ equals 1. We can solve this problem in two methods. Either we can use first type 1 or Lagrange's method. So P plus Q equals 1. We can solve this problem by type 1, but here the answers are phi of x plus y, y minus z, f of x minus y, y minus z. In this manner, the answers are given. So small p coefficient is, I am going to use Lagrange's method based on the options. So Lagrange's method, small p coefficient is capital P. So here the capital P term is 1. Small q coefficient is capital Q. Here also coefficient is 1. R is 1. Now substitute equation, dx by 1, dy by 1, dz by 1. So comparing 1 and 2. So integral dx equals dy. X equals y plus c. X minus y is equal to c. And finally, we can take x minus y is equal to u. Similarly, if you compare y and z or x and z, we can take, if you compare dy by 1, dz by 1, we can get y minus z. So, option is x minus y, y minus z. So, option 3 is correct. Next one. Question number z square equals pq. Question number 10. Question number 10. Z square equals pq. If the function contains p, q, z is equal to 0, then this is a type 3. For type 3, this is type 3 because here z, p, q, only 3 variables are used here. So this is type 3. Type 3, the solution procedure is, first let z equals f of x plus ay be the solution. Be the solution to 1. If I am considering this as 1. Solution to 1. Next, put u equals x plus ay. Then by applying chain rule, du, that is p value equals dz by du, q value is a into dz by du, a into dz by du. So put it in 1. Now substitute p and q value in 1. So 1 z square is equal to pq. In place of p dz by du, in place of q a into dz by du. Z square equals dz by du, a into dz by du. Z square equals a dz by du the whole square. Now taking square root on both sides, z equals root a dz by du. Now use variable separable method. You should combine z term on dz, remaining term on du. So dz comes denominator and du divided by root a equals dz divided by z. Integrating on both sides. 1 by root a du equals dz by z. Now 1 by root a du integration is u, dz by z is log z plus some c. U value is x plus ay divided by root a equals log z plus c. Now x plus ay, so if you do cross multiplication, root a log z plus root a c. So x plus ay minus root a c equals root a log z. But this minus root a c can be considered as the single constant c, because we have to compare the answer with the existing answer and our derived answer. So x plus ay minus root a c considered as c, root of a log z. So first one will be the answer for this question. And now the solution which has number of arbitrary, where number of arbitrary constant equals number of independent variables, this solution is known as complete integral. Next one, the complete integral of p square plus q square is equal to x plus ay. So p square plus q square is equal to x plus ay, x plus y. Here 4 variables, so type 4. So type 4, or in type 4, compare p square term with x, q square term with y. After that equate to some constant, either a or b. So I am using k. Now p square minus x is equal to k, y minus q square is equal to k. P square is equal to x plus k, y minus k is equal to q square. So p is equal to square root of x plus k, q is equal to square root of y minus k. Now what is the solution for type 4? Solution for type 4 is integral dz is equal to p dx plus q dy. Integral dz is equal to p dx plus q dy. Px plus q dy. Z equals p value is root of x plus k plus root of y minus k dy. Z equals x plus k, root x plus k is x plus k power half. Half plus 1, 3 by 2 divided by 3 by 2 plus y minus k, half plus 1, 3 by 2 divided by 3 by 2. 3 by 2 plus some constant c. So z equals 2 by 3, x plus k 3 by 2 plus by 3 y minus k 3 by 2 plus c. This is our derived answer. You can compare with the options x plus k, y minus k. So x plus a, y minus a. So this is the answer 2 by 3. Instead of k they are using a. X plus a 3 by 2, 2 by 3, y minus a 3 by 2 plus some constant c. So option 3 is our correct answer. Now the next one. So this is a cubic equation solved. So right hand side is 0 here. So we have to solve for left hand side. Only find complementary function. So first write the auxiliary equation. What is the procedure for writing auxiliary equation? Replace your d by m and d dash by 1. So what will happen here? M cube minus 7m minus 6 equals 0. Just use this equation. M cube coefficient, m square 0, m minus 6. You can use minus 1 or plus 1 by trial and error method. I am using minus 1. So minus 1, minus 1, plus 1, minus 6. So the remainder is 0. M equals minus 1 is one of the root term. This is constant term. Now the cubic equation is reduced to quadratic expression. This is m term and this is m square term. So m square minus m minus 6 equals 0. You can factorize this expression minus 6. So 3 into 2 minus 3 minus 2. M minus 3 m plus 2 equals 0. So the values of m are 3, minus 2, minus 1. This is our values of m. Now they are different values. Roots are distinct roots. For distinct roots, what will be the solution? Complementary functions z equals f1 of y plus m1x plus f2 of y plus m2x plus f3 of y plus m3x. Just substitute minus 1, minus 2, 3 in place of m1, m2, m3. So m1 value, m2 value, minus 1, minus 2, plus 3. Here minus 1 plus 2. This is not correct because m1 value minus 1, 2 negative values, minus 1, minus 2 and 1 positive value. So here this is not correct. This is not correct. This is the only solution for our question 13. Question number 13. Next one. Question number 14 also the same procedure. Replace question number 14. Characteristic equation. Characteristic equation, replace d by m cube minus 3m square equals 0. When you consider m square as common, m minus 3 is equal to 0, m is equal to 0, 0 and 3. So here two roots are repeated and one is the different root. Zc is equal to f1 of y plus m1x. So this can be considered as this is m1, this is m1 and this is m2. X into f1 of f1 or f2, y plus m1x. For the first repetition you have to add x. Suppose the third root is also the same root, you have to multiply x square. So third root is different, y plus m2x. Now zc is equal to f1 of y, m1 is 0, plus x into f2 of y, f2 of y plus f3 into y plus 3x. So compare the answer. Yeah, f1y, x into f2y, y plus 3x. So third value is our answer. Similarly for this problem also we can solve. So complementary function only for left hand side you have to solve. Next one. Question number 16. Particular integral. We have to find the particular integral for d cube minus 2d square. The procedure for particular integral is question number 16. 1 divided by our given expression d cube minus 2d square d dash e power x plus 2y. You just replace, put x is equal to a, put d is equal to 1. That is the coefficient of x in e power x. And d dash coefficient of y in e power 2y. So d dash is 2. You just substitute the values. 1 cube minus 2 into d is 1 and d dash is 2. Now 1 divided by 1 minus 4 e power x plus 2y. 1 by minus 3 minus 1 by 3 e power x plus 2y. So minus 1 by 3 e power x plus 2y is our answer. Next one. Question. The particular integral of d square z equals x cube. This is so simple one. 17th question. So question number 17. Particular integral 1 divided by d square x cube y. Here we are having only d square term. There is no other term. So for d square, just integrate this function. Integrate this function with respect to x 2 times. Because always d represents x. So let me take x cube y. First I am going to integrate with respect to x. X cube integration is x power 4 by 4 y. Next integration. X power 5 divided by 5. Already we are having 1 4 here y. So x power 5y divided by 20. So x power 5 divided by 20. First option is correct answer. Next one, question number 18. The partial differential equation is of the form. We have to find the classification. Which class we can to find whether the partial differential equation is parabolic type, elliptic type, or hyperbolic type. So for that, we need to evaluate the value of b square minus 4ac. If b square minus 4ac less than 0, the equation is elliptic. Greater than 0, hyperbolic. Your PD is hyperbolic and exactly equal 0, then it is parabolic type. So here, what is ABC? General form is AUXX plus BUXY plus CUYY. UYY coefficient is C, UXY coefficient is B, UXX coefficient is A. Here the given expression is UXX minus UYY equals 0. Here A value is 1, there is no B term, so 0, C value is minus 1. So B square minus 4AC value, B is 0 minus 4 into A into C. So 4, which is positive. For positive, the given equation is hyperbolic. So our equation is hyperbolic. Next one, sin HY. Sin HY. So we have to find the particular integral only. So sin HY can be written as e power y plus e power minus y divided by 2. So 1 by 2 1 divided by 2 e power y minus e power minus y. So 1 divided by 2. How can we find the particular integral? Left hand side is 1 divided by d square plus 2dv dash plus d dash square e power y. Y means 0x plus 1y y, and minus this minus 1 divided by d square plus 2dv dash plus d dash square e power 0x minus y. Now the procedure for finding particular integral is just you have to substitute the values of coefficient of x in d, y in d dash. So 1 divided by 2. Here x is equal to 0, here b is equal to 0 and d dash is equal to 1. b 0, here 0, d dash 1, so just 1 e power y, and here minus d 0 but d dash is 1, d 0, d dash is 1, so here also d dash is minus 1, so d 0 0, here 0, when you substitute d dash is equal to minus 1, d dash the whole square is 1 only, so again 1, but e power minus y. So what is our particular integral? E power y minus e power minus y is 2 times of sin hy. So 2 and 2 get cancelled. Sin hy is the exact answer. Next one, the complete integral of the complete integral. Important question. Question number 20. Question number 20, complete integral. So this is of the form, the function z equals px plus qy plus some function of p comma q is Clairaut's form. So here for Clairaut's form, the initial procedure is to find the complete integral. How can we find the complete integral for Clairaut's form? Just replace p by a, q by b, that's all. So z equals ax plus by plus a square plus b square. So first one is our answer. Rest of the things, the same procedure only. So question number 21, already it is in complete integral. Z equals ax plus by minus 3ab. We have to find the singular integral. For finding singular integral, the procedure is Equate dou z by dou a equals 0, dou z by dou b equals 0. From this we have to find the values of a and b. Now I am equating dou z by dou a is equal to 0. First dou z by dou a, what is the value? Differentiate z with respect to a. A is 1. So x. Here there is no a term, 0 minus 3b. So x is equal to 3b. X by 3 is equal to b. Dou z by dou b. Differentiate z with respect to b. Here 0. B is 1. So y minus 3a. B is 1. So y is equal to 3a. Y by 3 is equal to a. Now substitute a and b value in our general form. Z equals a. A is y divided by 3 and x. Here I am substituting z is equal to a values y divided by 3 x and x plus b. B is y divided by so this is our a value, b value. Z is equal to a value is y divided by 3 in x. B value is x divided by 3. X divided by 3y minus 3 into again a value, b value. A value is y divided by 3, x divided by 3. So simplify further. Xy by 3, xy by 3, here 1 3 get cancelled, minus xy by 3, xy by 3, xy by 3 get cancelled, so that is equal to xy divided by 3. So when we do cross multiplication, 3z equals x into y. So this is our answer. Next one, the partial differential equation is elliptic when b square minus 4ac value is less than 0, not less than or equals, less than 0. This is our answer. So here also we have to do the same method on degree and order of degree and order. Degree and order. What is degree and order? The highest derivative. So here highest derivative is dou cube z by dou x cube. Dou cube z by dou x dou y square. So 3 is the degree and 2 is the order. So 3 is the degree, 2 is the order. And next one, x square fxx fyy. Here also a value is in question number 24. A value is x square. There is no b term. 1 minus y. There is no b term. Right. So question number 24. A term is f double x coefficient x square. B term there is no fxy. And C term is 1 minus y square. But we have to find elliptic in the region. This expression is elliptic in which region? So first you have to calculate b square minus 4ac less than 0 for elliptic. So there is no b term. 4 into a term is x square. B term is 1 minus y square. You just replace this symbol. So taking minus outside. So minus into minus plus square. Y square minus 1, but this should be less than 0. When it should be less than 0? First thing, this should not be 0. This should not be 0, but y square value, when y value is less than, modulus of y value is less than 1, so we can get the value is elliptic. Next one, p tan x q tan y equals tan z. So capital P is equal to tan x, capital Q is equal to tan y, and R is equal to tan z. This is Lagrange's method. For Lagrange's method, you have to write the subsidiary equation and then solve. So dx divided by tan x, dy divided by tan y, dz divided by tan z. So first comparing these two, dx by tan x, dy by tan y. So 1 by tan x is cot x. And 1 by tan y is cot y. So integrating on both sides, cot x integral cot x is log sin x, and integral cot y is log sin y. So add the integrating constant as some log c. So log sin x minus log sin y equals log c. log of log m minus log n, log m by n, log sin x by sin y equals log c. Log get cancel. Sin x divided by sin y equals sum u. Similarly, when you equate these two terms, we will be getting sin y divided by sin z. So our solution is first one. So after this multiple choice question, there are various types of multiple choice questions are discussed here. Based on that, we can solve n number of multiple choice questions.